The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, thanks for joining our webinar on LINKPlanner Basics. We have one of our regional technical managers, Brian Chan, to help walk you through how to use some of the more basic and maybe a little bit some of the advanced techniques of LINKPlanner. So if you have any questions, feel free to type them into the text box on the right. And as always, just type them in as you see fit, and we will get to the questions throughout the presentation. So without further ado, here's Brian.
Thanks, Colin. So I'm Brian Chan. As Colin mentioned, I'm a regional technical manager, and I cover the South Central United States. So today I'll be talking about LINKPlanner and this design tool that we offer, and you can download it from our website. And I'll also plan some point-to-point links in unlicensed as well as licensed frequencies, as well as point-to-multipoint links so you can see the capabilities of LINKPlanner. I'll also show you how to read the throughput and reliability calculations of each of the paths, and we'll also go into some of its capabilities in terms of generating bills of materials, as well as installation and proposal reports. So before I get started, can you see my screen, Colin?
Yeah, you're okay.
Okay, perfect. So for those of you who are new to LINKPlanner, you can download this tool by going to our website. It's just www.cambiumnetworks.com, and if you go to Products and then Software Tools, if you click on LINKPlanner, it'll actually take you to the page where you can download our software. So if you scroll all the way down to the bottom, there's a big button that says Download Now, so you can click on that. So for those of you who don't already have it and you want to follow along, you can go to our website and download it, get it installed, and follow as I plan point-to-point and point-to-multipoint links. So that download button actually takes you to our support website. So this does require you to create an account if you haven't already done so. And we do have 2 installers for Windows as well as Mac. So if you are using a Mac, we do have software for you as well. So once you get that installed, this is what LINKPlanner looks like when you first open it up. So as you can see, there are a few different fields in here that show you a quick tutorial if you are getting started for the first time. So this is a quick guide with some information on getting started for planning point-to-point or point-to-multipoint links, some of the different concepts on non-line of sight and line of sight paths, the different link architectures, and basics that are going to help you figure out how to plan some links. Also, there's contact details, so depending on where you are, it will show you who you can reach out to for support. So this is the sales staff that supports South Central, and also a list of recent projects that you can quickly open. So if you want to create a project for the first time, go to File up in the menu bar, and then click on New Project. And this is what the interface looks like for the main project file. So under General Information, you can fill it out with your information for your customer, or if it's yourself, project description. Under Project Properties, this is where you can select either one of 2 different options. So depending on where you are, you're going to want to select I2-R if you are in Europe or Asia or South America. For North America, you're going to want to select the Gantz-Barnett. So these prediction models dictate how the rain rates are modeled and how worst earth curvature is modeled. So if you select the wrong one, it's actually going to give you predicted performance that is not necessarily accurate for your region. So for North America, you definitely want to select the Gantz-Barnett because this is a little more conservative and it's more accurate for the region. If you select I2-R for North America and then deploy a link, you might find that the prediction calculation was actually overly optimistic. So it is very important to select the appropriate option here depending on where you are. And then here in this map, you've got 2 tabs, one for an offline map, which shows a grid system with distance markers, and then there's also Google Maps, which has the Google Maps overlay for all of your coordinates. And if you click on Satellite View, it actually shows the satellite overlay. So if I zoom in, I can actually see all of my buildings and obstructions and trees. So it's definitely very useful if you want to quickly plot some coordinates in areas or buildings that you do not already have coordinates for. So before I get into I guess importing or plotting access point sites and subscriber module sites, I'm going to go into tools and show you guys how to get started in customizing LINKPlanner, I guess, for your account. So if you go to tools and options, these are all the details that allow you to customize LINKPlanner. So under personal information, you're going to want to give it your name as well as your email address. So this is actually used for path profiles. So it's important that this is a working email address. Under templates, you can actually create a template file so that every subsequent project starts out with the parameters that you've entered into this template. So like I mentioned earlier, if you're in North America, you always want to create a project with VGANTz/Barnet. If you're in the rest of the world, you want to use ITU-R. And ITU-R is the default setting. So if you're in North America and you don't want to change it from ITU-R to VGANTz/Barnet every time you open a project, then you're going to select VGANTz/Barnet and you're actually going to save that file as a PTP template file. And once you've done that, under templates, under new project template, you can then select the template that you've created, and then after that, every project that you create, every new file, will adopt these parameters, and it'll open up with this VGANTz/Barnet setting. So it does save a lot of time, and it also eliminates the risk that you might accidentally leave it on the wrong setting and plan links in the wrong prediction model. Under units, the default is SI, so if you're in North America, you probably want to change this to imperial, like feet and miles. So this is where you would select the appropriate unit that you would want to use for height, as well as your link lengths or distances. Lat longs and MAC addresses probably don't matter too much, but these are the different formats that you can choose from, either degrees and decimal format, or degrees and minutes, or degrees, minutes, and seconds. And the MAC address is actually a field that you can enter in your PTP links, and so it's either in decimals or a dash. The default regions, so these are the different frequencies that you can plan point-to-point links in. So this is a full list of licensed as well as unlicensed frequencies. And by default, it's actually organized alphabetically. So for the frequencies that you know you're going to use, you're going to want to click on the frequency and then select your region, and you're going to want to click that region up to the top. So for example, I believe Argentina was at the very top of 4.9. United States, which is the region that I'm in, was somewhere down in the bottom. So I had to click on United States, and I had to click for it to go all the way up to the top. If I wanted Belgium to be at the very top, for example, I would select that and then click that to go up to the very top. I don't want to save that change, so I'm going to set it back down and then hit cancel. But this is really a time saver, because every time you plan links in the bands that you know you're going to use, if your appropriate region is at the very top, then you won't have to select that drop down and then change it every single time. The same goes for point-to-multipoint regions. So our point-to-multipoint platforms only operate in the unlicensed space. So as you can see, there's a shorter list compared to PTP, where we do have licensed frequencies. Network settings, I don't think you have to make any changes there. Path profiles, so if you're using this for the first time, if you get set up with an access token, which I believe you have to go to the support website for, basically just follow the instructions here if you're using it for the first time. I'm already set up, so my page might look a little bit differently from yours. But if you set this up, then every time you create new links, they will automatically populate in LINKPlanner. So again, this is a huge time saver. If you don't set this up, then every time you create a link, you're actually going to have to go to Project and then Get Profile and then select the links that you want to download those paths for. So getting this set up is a lot more convenient. Reports, so we do generate proposal as well as installation reports, and this is something that you can then hand off to your installers, and it has all of the information that they'll need, like up tilts, down tilts, azimuths, antenna gains, and that kind of information. So if you want to change like your font or your page size, you can do that here. Under graphics, you'll notice once I get into the link planning that each of these sites and links have different colors in the legend. So network sites are defined as red dots and subscriber sites are defined as blue dots. If you deploy a point-to-point link, whether it's unlicensed or licensed, it will be green in a solid style, and point-to-multipoint links are blue. So these all can be changed if you feel like you want a different color scheme. The bill of materials is another really nice feature of LINKPlanner. So once you create these links, LINKPlanner populates a bill of materials automatically, showing you all of the different equipment that you need to order to make those links work. And if you don't have this checked, then it will actually show no part number for the power leads for the power supplies. If you have it checked for your appropriate region, then the bill of materials will have the appropriate lead, and it will show you all of the appropriate details for the power supplies that you're going to need for your overall bill of materials. So now that we've got that all set up, I can now talk about plotting some coordinates and planning links. So I live in the Austin area, so I've zoomed in on Austin here in Texas, and this is with the satellite overlay. So if I have coordinates that I want to enter in, I can go into Project and then Use Network Site. So you're going to see that there are two different sites that I can plot, Network and Subscriber. So a network site is defined as any PTP link end or point-to-multipoint access point. So those are network sites. Subscriber sites are just the subscriber modules that would then connect to an access point. So those are the definitions. So if I want to plot a point-to-point link, I would have to click on network site and then enter in the coordinates. So this will take it either in decimal format or degrees, minutes, seconds. If I don't know the coordinates and I wanted to find a location, I could actually just zoom in. So for example, if I have maybe an office building and the customer has asked me to plot a point-to-point link, and he's basically just told me where his address is, I could look up the address in Google Maps or in Google Earth, find the location of that building, and then basically come to LINKPlanner, and then I could then use a shortcut, and then I could click on that shortcut on that building. So the shortcuts within Google Maps allow you to drop a pin. The shortcut in the menu bar with the exact same icon is actually looking for coordinates. So even though these two shortcuts look identical, they are looking for different types of information. The same thing goes for being in the offline map tab. If I click on that same icon, it's now looking for coordinates as opposed to allowing me to drop a pin. So going back to Google Maps, if I knew that this was my location, I would then click on it, and it would then automatically populate the lat long and allow me to enter in the name as well as the maximum height for that building or for that tower. Another option for entering coordinates is to import the network sites or subscriber sites from KML, KMZ files, which are basically Google Earth files, or CSVs. So I have saved some sample sites that I just created. So I have a combination of network sites as well as subscriber sites. So I'm going to go ahead and import network sites from a CSV. So I've got two CSVs here, network sites and subscribers. So I'm going to import the network sites first. So as you can see, this is what the format looks like for this comma delimited file. So it does have to be a specific format of Excel. It's not your typical Excel format. It is a .csv. So now these are the different fields, and I just have to make sure that the fields line up with the information that LINKPlanner is looking for. So these are all the site names. So it is under the name column. These are the latitudes. These are under latitude column, and these are under the longitude column. So these are all correct. If one of these was swapped, I could change it and change this to longitude and change this to latitude, for example. So changing it back, this is also the max height, so you want to make sure that that is populated accurately as well. So now that I've ensured that all of my information is correct, I'm going to click Next. It shows me where my sites are in the offline tab, just with the distance markers. Once I click Finish, it should have imported my coordinates. So if I click on Home, it will actually zoom to fit. So yeah, so I now have all of my network sites plotted in the downtown area of Austin. So if I feel like the satellite view is showing too much information and it's too cluttered, I can turn that off by clicking on Map. So now this is a much cleaner view. If I just wanted to see them in white space, I would click on the offline map. So next I'm going to want to import my subscriber sites. So I'm going to import subscriber sites from CSV. I can now select my appropriate CSV file, hit open, and basically go through the same process as we just did for the network sites. So you can see that by this West Lynn network site, we have about 5 to 10 subscribers plotted. So now that we have our coordinates entered in, this is where we can start planning our links. So,
hey Brian, I actually have a quick question.
Oh, go ahead.
Under project properties, when it says SM antenna height, is that if you change that value? The project properties field right above the map field, next to VGen SparNet.
Oh, sure.
Is that a master number there? So like if you change that, will it change the default SM height to whatever that says for all SMs?
Oh, that's a great question. Yeah, so this is actually the global parameter that will automatically populate all of the SMs with this height. So for example, if I came into my subscribers and I said that the maximum height was, so this one says 108, this one says 108. So if they're all at certain heights that are greater than 33, once I plot my point to multipoint links, they're actually going to adopt this setting no matter what my maximum SM height is. So if you know that most of your SMs are going to be maybe 15 feet, then you're going to want to change this to 15. For the purpose of this planning session, we're just going to leave it at the default setting of 33 feet.
Okay, great. Thanks.
Sure. All right, so planning point-to-point and point-to-multipoint links requires you to basically click between 2 points. So you can either do that using this shortcut bar or shortcut icon here in this menu bar that says New PTP Link, and you can select the 2 different sites. So for example, if I wanted to connect the State Capitol building to the Frank Erwin Center, I would select Capitol and Frank Erwin and then hit OK. Once that's done, you'll notice that PTP Links now has a link that has been created for me. The default setting for new links is unlicensed 5.8. So we'll go ahead and change that to take a look at the different bands and whether it's licensed or unlicensed. But if I wanted to plot another point-to-point link, for example, using a different method, maybe I wanted to just point and click between 2 sites, I would use the same icon but within the Google Maps button. So if you'll notice, the general theme is that the icons and shortcuts in the menu bar require you to enter in information. In Google Maps, if you click on that same icon, it's letting you drag and drop. So clicking on that shortcut, I can connect the Capitol building by clicking on it and then clicking on this West Lynn network site, and this creates my second point-to-point link. So Capitol to Frank Erwin Center, this is only a half-mile link. So if the customer wanted this to be a licensed link, they would probably use a pretty high frequency, like maybe 18 gigahertz or 23 gigahertz. If they wanted it to be unlicensed, they would most likely use the PTP 650 radio, which is our flagship unlicensed radio, and that's a wideband radio that operates from 4.9 up to 5.8. So let's start out by just planning an unlicensed link. So 5.8 is a pretty common unlicensed frequency. You can go ahead and take a look at what the performance would be like in 5.8. So we'll leave that on the 650 product line. Other options are in this drop-down menu as well, and they include some of our legacy radios like the PTP 600, 500, and 400, as well as the PTP 450, which is more of a lower cost budget radio, and then also ePMP, which is also low cost. PTP 700 is also another option, as well as the 670, which is going to be released here pretty shortly. So in terms of capacity, depending on what you select, this is what will affect the parameters for throughput as well as your bill of materials. So if you set it to full, this is where you get the full spectral efficiency of the radio. It's 10 bits per second per hertz. If it's light, then it's roughly 3 out of 8 bits is usable, and the other 5 is being bit stuffed. So in order to remove that overhead, that would require a license key to upgrade to the full capacity. So for our planning purpose, I'll go ahead and leave it for a full capacity to take a look at what the full capacity of the 650 radio is. Regulation, so select the appropriate country for where these links are located. Here in Texas, we will select United States. Network timing, as if you're doing, I guess, some kind of IEEE Sync-E type protocol. Bandwidth, so this is where you can select the different channel sizes. So depending on your throughput, you'll want to use a very efficient or optimized channel. So if you only want 50 megs of throughput, for example, I would probably use a smaller channel, because the larger the channel, the harder it is to find clean spectrum, and also the higher probability that you're going to be interfering with other links if you don't have PTP sync enabled and a lot of links in that area. So just to see what the capacity of the 650 is, we'll go ahead and select the largest channel size. E1s, T1s, this is capable of running TDM traffic. We won't select that. We'll optimize it for IP traffic. Sync, this is only if you are synchronizing multiple PTP 650s within a network. Since we only have 2 links, we'll just go ahead and leave this disabled. Symmetry, so this can be adaptive or symmetric, and there are several different options that you can select. So if you know that more traffic is going in one direction than the other, you can select 1 to 5, 1 to 3, 1 to 2, or the inverse of that. Dual payload will enable that. Will enable the highest modulation mode of 256 QAM. Okay, so this is what the link looks like. So this is the 2D terrain profile, and you'll notice that this is the Earth's curvature, and this is the link with the Fresnel zone. The nice thing about LINKPlanner is that it integrates directly into Google Earth. So if I wanted to do a virtual site survey and see if there were any obstructions like buildings or trees that lie along this path, I would then select this shortcut icon for Google Earth. I would click on it. It would open up my Google Earth program, and it would then plot my path in Google Earth and allow me to take a look at all of the different obstructions in that link. So I've got this set to 308 feet. I think I might have been a little aggressive with that. And I think that also the way it's modeled, I think it's a little bit too high. But so it does show the distance markers of the path. So if I go back to my LINKPlanner path, you'll see that these are all of my distance markers. And so these distance markers are also in Google Earth. So here's my Frank Irwin Center at 108 feet, and my Capitol building at 306 feet, I believe. At 0.1 mile, there is a building that's maybe 2, 4, 6, maybe 10 stories, so maybe that's a 120-foot obstruction. So if I wanted to see if that would have an impact on my path, I would click on this 0.1 mile marker, double click on it to where I could edit the profile, and then enter in that obstruction height of 120 feet, hit enter, and it would then automatically populate with that obstruction in my path. So this is really nice because it allows you to determine if certain obstructions were infringing upon the Fresnel zone and turning your line of sight path into near line of sight or even non-line of sight. And you would see that the performance summary would also automatically update with that information. So continuing on down that path, there's also another building here at 0.2 miles, but that's fairly short, so chances are this is a true line of sight path. So now that I know that this is line of sight, I can take a look at my link summary and determine whether or not additional changes are required for me to meet my requirements. So this is telling me that my aggregate throughput is 453 megabits per second, and my calculated reliability is 100% with an annual overall downtime of 0 seconds per year. Because the predicted receive level of neg 35 dBm is a very healthy level, and since it's a very short path, even if there were rain fade or ducting events, they would likely not be severe enough to degrade my receive level down below the receive sensitivity for my different modulation modes. So this is a really short path, so it is a slam dunk. Even if you use really small antennas, the performance is going to be really good. One thing to note, however, is that for unlicensed links, LINKPlanner doesn't automatically check interference. You have to do that manually. So this typically does have a pretty drastic impact on your link. Since this link is so short, it hasn't really had much of an effect on it. But it is very important to check interference for unlicensed links. And that's because without it, LINKPlanner will assume that there is no noise in that unlicensed band that you've planned your link for, which is not realistic. So the values that LINKPlanner populates with the default values when you check it are average values that you may find typical for urban environments. So if you know that your area has higher or lower noise, you can certainly adjust this parameter to make it more accurate, to have a more accurate prediction for your performance summary. So any questions, Colin, on unlicensed links?
It looks like someone tried to ask a question, but it got messed up. So if you want to try that again, we could definitely get to that question. I actually did have a question though. For when you put in obstructions, is there any sort of guidance as to like what type of obstruction it will be? So for example, if it's a building or like a really large tree, you know, one of those might have different reflective properties and mess with your link in other ways. And is there any way to tell what kind of obstruction it is in LINKPlanner?
Right, that's a really good question. Yeah, so there is not a way to tell in LINKPlanner. So the way LINKPlanner, I guess, models these obstructions is they are modeled as solid objects. So if you put in an obstruction and it's a tree, you can't tell LINKPlanner that what you just put in was a tree with certain properties for absorption and reflection. It's just treated as a solid object. So modeling non-line of sight links is not very accurate in LINKPlanner because it models it as a worst case scenario. So chances are if you're going through some trees, since a lot of these unlicensed radios are OFT MIMO radios, they are capable of connecting in non-line of sight environments, but LINKPlanner may tell you that it will not connect even though it may connect. So with non-line of sight links, you just have to be careful. You can use it as a guideline, but chances are it's going to be overly conservative.
Okay, great.
Did you get that question? Did someone else send?
No, it looks like that never came through. So, and this is to all people. If you have any questions or if you'd like Brian to clarify anything about what he's gone through today, please feel free to type that out now.
Yeah,
Brian,
feel free to ask questions and we can turn this into more of a discussion. But if there are no other questions, I'll just proceed. So under Performance Details, there are two tabs. One is a chart and then one is details. So in this chart, it models availability as a function of capacity. So as I hover over it, it will show me my anticipated throughput as well as reliability for the different modulation modes. I prefer looking at the details table. So this shows me a breakdown of every single modulation mode as well as my throughput. So here's my maximum throughput in each direction as well as my fade margin and my mode availability as well as the predicted time that the link will spend in each modulation mode. So this goes all the way from 256 QAM dual payload where it's sending two unique streams of information across both polarizations all the way down to BPSK in single payload where it's sending the same stream of information across both polarizations. So again, this is an OFT MIMO radio, so it is transmitting across two different polarizations. So looking at 256 QAM dual payload, it tells me that my maximum aggregate throughput is 453 megs. my maximum throughput in each direction could be as high as 407. Again, this is because I selected adaptive for the link symmetry, and so 453 megs is my overall link throughput. Since this is a TDD radio, it's transmitting and then listening and then listening and then transmitting. So since it's sharing the medium, we do have the capacity to change the link symmetry. So if it's 407 megs in one direction, then the other direction will be the remainder of the 453 megs. So it's not 407 in both directions. The fade margin, so that's pretty important to know. So it does show the fade margin for each of the modulation modes. So if the link were to fade, this link could withstand up to a 35 dB fade before it dropped below the receive sensitivity for your lowest modulation mode of BPSK. The mode availability is also very useful, so it's showing me that for 256 QAM, it's 99.9807%, which means that I will spend that amount of time in 256 QAM. Once it drops below the received sensitivity of 256 QAM, I would then spend the remainder of my time at 64 QAM. And because this link is so short and the receive level is so high, it is not expected to drop down into the lower modulation modes below 64 QAM. So this gives me a really good idea as to the behavior of this link and the overall performance in terms of throughput as well as reliability. And here at the very bottom is a bill of materials. So this does include all of the equipment that I would need to make this link work, from grounding kits to my actual radios to my link upgrades or software keys, as well as dishes if I had any dishes, power supplies, and things of that nature. You could also export this to Excel, and then you could then send this to your VAR or your distributor, and they could then give you your pricing for all of your equipment. So that is an unlicensed link. I can also plan a licensed link now, which should go by pretty quickly since we've got a pretty good idea as to how to go about planning links. So the different license frequencies that we can choose from include 6, 11, 18, and 23 gigahertz. Here in North America. So this being a very short path, I could probably get away with 18 or 23 gigahertz. I'll go ahead and select 18 since that does allow me to use 80 megahertz channels. 23 gigahertz only goes up to 50. So this will showcase the maximum throughput of a licensed radio. So 820 is our flagship licensed radio. So this is a single core radio if it's an S and a dual core radio if it's a C. So with a PTP820C and a wideband, we could achieve about 1.2 gigs full duplex. So let's take a look at this link and see if we can get that maximum throughput out of it. So under link type, this is basically the architecture of the link, and these are the different options you can select for this licensed link. If I'm going to do 2+0, I can either have both channels in the same polarization, being adjacent to each other, or being in different polarizations, or I can select XPIC, which is the most spectrally efficient, where I'm actually reusing that frequency in both the horizontal as well as vertical polarizations. So let's select XPIC for this link. So now that I've selected 2+0, you'll notice that there are two links under my main link, link A and B. So these are vertical and horizontal links. And this is my overall path where I can make global changes. If I wanted to make changes specific to one of those cores, I would have to select either link A or link B. Remote mount is if I were to mount the radio separate from the dish, but we don't want that. We want to mount it directly to the dish to minimize losses. Under Ethernet configuration, multiple Ethernet with lag would mean that you're creating a link aggregation group within the carrier grade switch in the 820 radio. If you did without lag, then you would create two services. So one radio would connect to one Ethernet port. The second radio would connect to the fiber SFP port. So let's go ahead and select without lag. So now I can select my different modulation modes. So I'm going to want to operate in adaptive modulation between QPSK up to the highest modulation of 1024 QAM in this 80 megahertz channel. Other options include header compression. So if I know that I'm transporting a lot of small packets that can greatly benefit from header compression and saving several tens of bytes, I can enable it here in header compression, and this would then actually update my aggregate TCP/IP throughput, and you can see that it's going to change based on the frame size. So if I have larger frames of 1518, you can see that it only went up by maybe 20 megabits per second, which isn't a lot. But if I'm using much smaller packet sizes, where saving 20, 30, 40 bytes of overhead is going to have a very huge impact, you can see that it went all the way up to 2.7 gigabits per second. And this is an aggregate throughput. So if you wanted to take a look at the full duplex throughput, you could come into Performance Details, click on the Details tab, and it would then be in this chart or this table. So with header compression enabled for 64-byte packets being transported across this link, I can expect almost 1.4 gigabits per second full duplex, which is very remarkable. Even with header compression disabled, we would see that our overall throughput in terms of full duplex numbers is still around 1.2 gigabits per second, or 1.1, which is still very high, just depending on the packet size. Okay, so now that we've covered that, I can dive into each of these links and see if the dishes need to change. So since the overall reliability is still very high, since this is such a short link, there's really no reason to change my dish. But if this were a longer link, like maybe 3, 4, or 5 miles, and it was putting the link's RSL to the test, I might have to increase my budget, my link budget, by creating more system gain, and we could do that by selecting larger dishes. So once I click on the dish drop-down, this gives me all of my different options that I can choose from for direct mounting the 820 to a dish. So here I've got 1-footers all the way to 6-footers. Global means that it's an Andrews or CommScope dish. NA and CALA is, I believe, radio waves. So if I did want to change that dish and get greater gain, I could select a larger dish. And here in this gain field, it does show me what my dish gain is. So it's 34.6 dBi for a 1-foot dish. If I wanted more gain, I could eke out another 12 dB of gain just on this end by selecting a 6-foot dish. And because this is a license frequency, the owner would then have the rights to this license frequency pair. So there's really no reason to check on interference because there shouldn't be any interference in a licensed link.
Hey Brian, is there a setting in unlicensed links to have the interference box automatically checked?
Not that I know of. I believe that needs to be checked manually.
Okay.
Yeah.
And actually, we have another question in regards to unlicensed links.
Sure.
And if the EPMP 2000 and the Force 200 radios show 5.1, 5.2, 5.3, and 5.4, then why does it now show up as available to the installers? They only see 5.1 and 5.8.
Let's take a look. So the question was 5.1, 5.2, 5.4 should also be covered by EPMP. So if we select 5.4, we can select EPMP. So if the question is regarding not being able to access those bands in EPMP in the configuration, then perhaps it's just an issue of firmware. I'm not sure. We can take that question offline and I can look into that. So if you have questions and you want to reach out to me offline, my email address is just brian.chan@cambiumnetworks.com. That's brian.chan@cambiumnetworks.com.
Yep, and this is another question that you might not be able to answer, but I'll ask it anyway. Are you planning to have any products for the E-band?
E-band, is that 2.5 gigahertz?
I'm actually not sure, but we'll see if you clarify. 80 gigahertz.
Oh, 80 gigahertz, not that I'm aware of. We do have new products on our roadmap for other frequencies outside of what we are currently operating in, but they're still confidential, so I can't disclose our plans for that quite yet.
Okay.
All right, so it looks like we have 20 minutes left, so I will quickly demonstrate how to plan a point-to-multipoint network, and then we'll talk about the different types of reports that LINKPlanner can generate. So as you can see, I've got a list of subscriber sites here, and those are closest to the West Lynn Tower. So in order to create an access point, you do have to define a network site as a point-to-multipoint hub. So to do that, you can click on the shortcut here, which shows APs on a tower. Once you click on that, you can select the appropriate network site and then designate the number of APs for that site. Since all of my SMs are north of my access point site, I just need one access point. And my starting azimuth, 0 degrees, is for north. So since all of these SMs are north of my access point, I will just keep it at 0 degrees. And then hit OK. So now that I've done that, you'll notice that there's now like a coverage pattern for that access point with all of my SMs more or less in the coverage area. So now I can click on PNP links. I can select my hub. So this is my hub showing that I've got one access point in 5.8. Once I expand that, I can click on my AP and then make any changes that may be necessary. So since my unlicensed link was in 5.8, if I wanted to be conservative, I might want to keep my unlicensed backhaul links separate from my multipoint APs, so I can select anything from 5.8 down to 900 megahertz. Let's go ahead and just keep it on 5.8 since this typically gives us the best performance since we can hit much higher EARP limits. 5.4 and 5.2 have much lower EARP limits, although most of these SMs are very close to the tower, so they would actually benefit from a lower frequency like 5.4 or 5.2, especially since they have lower interference. But just to keep things simple, I'll just leave it on 5.8. For my product, I can select anything from 450 or ePMP. So for the access point, we would want to select 450i. So this does have better performance relative to a 450. It is a wideband radio. It has a dynamic interference filter, has faster processing power, as well as better system gain. And I believe the 450 APs are being discontinued, and they are being replaced by 450i. On the SM side, however, all 450 SMs are not going away. They are backwards compatible with 450i, as well as 450M access points. Country code, again, we want to select the appropriate country code. For sync input, if I were to synchronize this, I would either select auto sync or auto sync plus free run. Since this is one single access point, I'm just going to generate sync. There's nothing to really synchronize it with. The different bandwidths are from 5 to 30 megahertz. So to see how much bandwidth I can get out of an access point, I can just leave it on 30 megahertz. SM range, you just want to make sure that the maximum range of the AP accommodates the furthest SM. So since most of these SMs are within 1 or 2 miles, I'm going to reduce that. So this range does have an impact on the duration of the transmit to receive timing gap. So the longer this range is, the longer that timing gap is, and the lower your throughput. Frame period, 2.5 or 5 milliseconds can be selected. So 2.5 milliseconds will give you about 3 to 5 milliseconds of latency. 5 milliseconds will give you slightly more throughput because your overhead as a percentage of your frame will be slightly less, so you get more usable throughput. However, your latency will double to 6 to 10 milliseconds, which for most applications and customers is still far below the requirement. Downlink data, if you're a wireless ISP and you're distributing data from an access point to where your customers can download Netflix and stream YouTube and stuff like that, you will probably want to max this out at 75 to 85%. So now I can select my antenna. So these are my different antennas that I can select from. If I select a 4.9 to 6 gigahertz sector antenna, that gives me the best performance. So I'm going to select that. Model beam width is at 90 degrees, but I can change this model beam width. This doesn't really change the performance. It just changes the coverage area that's shown in LINKPlanner. So since 90 degrees is my 3 dB roll-off and 120 degrees is my 6 dB roll-off, I can still connect clients that are within that 120 degree area. Just the ones on the edges are getting less antenna gain compared to the ones that are directly in front of it. Antenna height, so for some reason this was at 984. I think this may have been, I think when I exported my sites, they were exported in meters, so that's why this is all 3 times higher than what I had anticipated. So we'll model this at 306 feet. No other changes should be required, so I'm going to go ahead and add my SM. So once I click on this button, every SM that shows up within that coverage area, within that map, can be selected and added. So once that has been done, I now get a list of all of my SMs, and looks like some of these may be non-line of sight. So if I expand this access point, I can now click on each of these SMs and take a look at their performance. So this says that my bearing to the AP is outside of the recommended range and performance is not guaranteed, and that's because looks like there's too much up tilt. So looks like installing at the very top of this location would not be ideal, so maybe I can bring it down a little bit to 100 feet. Okay, so that looks like it has resolved my problem. So before there was too much required up tilt for each of these SMs. So here I can change my antenna height, and I can change my product. So this is selected as 450i. If I just wanted to use a regular 450, I could select that. Once I do that, I can actually select the different antennas. So either it can be just a naked integrated antenna, which has 9 dBi gain, or I could select the integrated with a clip, which is just a Cassegrain lens antenna, which slips on directly over the SM. So that increases the gain an additional 9 dB. Since these are so close, it looks like my performance is just fine with a normal integrated SM. And then this shows me my tilt. So since all of these have around 10 to 12 degrees of up tilt, I'm going to improve performance by putting in down tilt. So I'm going to go ahead and put in 10 degrees of down tilt. So that way the AP is optimized for performance towards the SMs. So scrolling down, again, I have my 2D terrain profile. If I clicked on the Google Earth button, it would show me that link over Google Earth. You can also select different minimum modulation modes, both on the downlink as well as on the uplink. And again, we do have performance details showing me my fade margin as well as my throughput for each of these modulation modes. Coming back to the AP, it does show me my overall performance. So it shows that on the downlink, 6 SMs will be at 256 QAM, 1 will be at 64 QAM, and then on the uplink, 6 are at 64 QAM, and 1 is at 16 QAM with an overall predicted performance of 204 megs. And if I tweak settings like antenna tilt and stuff like that, maybe receive powers, maybe like target receive powers, should be able to maybe improve this a little bit more. So again, there's a bill of materials for the AP as well as the SMs, showing you the list of materials for your overall project. Any questions on that?
Not yet. Feel free to type them in. Brian, if you have any last-minute things to cover in the meantime while we're waiting for some questions to come in.
Yeah, sure. So I haven't really shown reports. That's pretty straightforward. So if you wanted to create a proposal report, for example, for your PTP links, you could select all of your PTP links and then click on the shortcut here for a proposal report. So it generates a PDF that you could use for a proposal, showing you the links, the coordinates, where they are, information about azimuths, up tilt, down tilts, the equipment that's used, path lengths, frequencies, performance. So all of that information is in this proposal report. Alternatively, you could also select installation report, which would have more information in it, which you could then hand off to your installer, because this would have more detailed information that they would need for installing these links, as well as point-to-multipoint links. So if I scroll down, I can see that it has information on my frame period, my bandwidth, all of the parameters that they would need to configure this radio if they were going to configure it. And then here in the physical installation notes, I've got my latitude and longitude, the antenna type, gain, antenna height, exactly where they would install that antenna, as well as the tilt angle, as well as the bearing from true north, as well as magnetic north, and the magnetic declination for those coordinates. So this is really useful from an installer's perspective. And then also, if you go into project configuration, going into BOM estimator, so I've shown you guys the bill of materials that is generated by LINKPlanner. If you didn't want to create an entire project to get an estimate or a quote, you could actually come into BOM estimator and then enter in whatever you needed a quote for, whether it's a licensed or unlicensed point-to-point link or point-to-multipoint project. It's just a really quick and easy way to generate a BOM. So for example, if I wanted a 58650 link, I would select that. If I wanted that link to be connectorized with maybe Cambium Networks 4-foot high-performance dual parabolic antennas, I would then select the appropriate antennas, and then once I close that out, my BOM estimator would then populate that list with the appropriate equipment. Same goes for a licensed link. If I quickly wanted to generate maybe an 11 gigahertz link with 820S and just leave it at 2-foot dishes, just close that out. I now have a full bill of materials for both 820s as well as 650s. And then I can export this to a workbook or just view it in a spreadsheet. If I export it to a workbook, it's really nice because it actually breaks it down into different tabs, with each tab representing different links. So here I can see that tab 1 is my 11 gigahertz link, tab 2 is my unlicensed 5.8 gigahertz PTP 650 link.
That's very useful. Can a link be exported to path loss 5?
I believe it can. And we actually, you know what? It depends on the type of link. So if it's licensed, I believe we can, and vice versa. If it's unlicensed, like the PTP 650, path loss doesn't have the ability to model our adaptive modulation as well as our ability to operate with OFDM MIMO very accurately. So we don't have path loss files for the PTP 650. We do have path loss files for 820 and a few other platforms. And regarding that specific question, I believe it is possible for some of our products, but not others.
Okay, cool. We actually do have one more. If we config our own sites using this tool, is there anyone we can send a copy to for confirmation? So this particular person's representative is Kelly Hatcher.
Okay.
So yeah, you want to go over that?
Yeah, sure. So you can, so if Kelly is your sales guy, you can send it to Kelly and or myself. I'm going to go ahead and just save this. So when you open up LINKPlanner for the first time, your contact details may be empty, but once you start planning paths, LINKPlanner will know which regional sales manager covers the territory for the coordinates that you've entered in. So if you plan a path in your state and it's in the states that Kelly and I cover, then it's going to have Kelly's contact information. If you plan paths in Western Canada, for example, it'll have Western Canada's RSM. If they're in Asia, it'll have that particular RSM. So basically just reference contact details once you've created paths and plotted in coordinates.
Great. I don't see any more questions yet. So if you have any closing tidbits of info, if not, I can just direct people to, if you have questions, please feel free to type them, I'm sorry, if you think of them later, I should say, please feel free to ask them in our community forum. It's a great place where you can talk with Cambium users or even get a direct response from us within 24 hours if needed. That being said, this webinar has also been recorded and it will be available on the community forum as well. So that being said, Brian, do you have any last minute things?
I don't. I believe I've covered everything.
All right. Well, thanks again, Brian, for giving the presentation, and thanks to everyone who joined. It was very informative, so everyone have a great day.
Thanks, everyone.